Hi guys, welcome to another maths lesson with A+ Tutoring. I'm Janiki and today we're going to be looking at 5 grade 9 NAPLAN-style word problems. If you haven't already, please check out the word problem lesson video linked in the description. Essentially, that was a lesson where I went through a step-by-step process for breaking down word problems. If you have already watched that lesson, please keep watching. Okay, let's have a look at the first question. As always, I make hope sure to this pause helped the you video tackle here word problems and like take a a pro. second for yourself to read Don't through the forget to like, question and comment, and understand what's subscribe for going more on. lessons. See you in the next video. Okay, now that you've had a chance to read through the question, let's go through it and find what the key pieces of information are. A cube has a side length of 5 centimeters. Calculate its total surface area. So to kind of help with this question, I've actually provided a diagram of a cube, but it's important to remember that, that won't be provided to you in every single question. Most of the time, you'll have to draw a diagram out for yourself. So with any kind of geometry-based question, anything with areas and volumes and things, I kind of tell all my students to draw a diagram out for yourself because it just makes your life a lot easier. And you'll see that in the case of this question as well. So now let's go through the information that they've given us. We can see that we're talking about a cube, so essentially all the sides are gonna have the same length, and that's why we've been given the piece of information saying that a side length is 5 centimeters. So if we just jot it down for ourselves, all these sides are going to be 5 centimeters in length. I'm not going to bother labeling every single side, but just keep that in the back of your mind. And we've been told to figure out the total surface area. Take a second to kind of think about how you would go about figuring out the total surface area. Easiest way to approach this question would be to think of it as calculating the total area using the faces of a cube. So the first step to this question would be to actually count the number of faces on a cube, right? So easiest way to do that is to look at the top face here and the bottom face here. So we've counted 2, and then we've got 4 that go like that, right? So in total, a cube has 6 faces. Now, let's get started with figuring out the area, right? Easiest way to go about it would be to figure out the area of one face. So and we know that a face in a cube is essentially a square, right? It's going to have the same side lengths, and figure out the area by going length times width, but in this case it's the same, so it's 5 centimeters by 5 centimeters, which gives us 25 centimeters squared, right? Now, what did we figure out before? A cube has 6 faces, so total surface area will equal 6 times what we figured out just then. 6 times 25, right? And you can do that multiplication on the side. If it's hard to do it in your head, 6 times 5 is 30, so put the 0, carry the 3. 6 times 2 is 12, plus 3 is 15. So your answer is 150 centimeters squared. Cool. Let's move on to the next question. Question number 2, as always, pause the video here and just take a second for yourself to read through the question. Okay, now that you've had a chance to read through the question, let's go through it together. A triangle has 2 angles measuring 35 degrees and 50 degrees. What is the measure of the third angle? So, we've been told that 2 of the angles in a triangle measure 35 and 50. All we have to do is figure out the size of that remaining angle. A core piece of knowledge that you need to know for this question is the sum of angles in a triangle. So essentially what that means is if you add up the three angles in a triangle, what's that total going to equal? In every single case, the sum of angles in a triangle will be 180 degrees, right? And we've been told the size of two of those angles. We need to figure out the remaining. So we can do a bit of simple algebra by assigning an unknown to the remaining angle and figure out the answer. So 35 degrees plus 50 degrees plus x for our unknown angle equals 180 degrees, right? 35 plus 50 gives us 85 degrees plus x gives us 180 degrees. X equals, and we can essentially bring that 85 to the other side. When we do that, it becomes a negative. So it's 180 degrees minus 85 degrees. If you have a bit of trouble doing that equation in your head, you can always do it on the side. 10 take away 5 is 5. 17 take away 8 is 95. So it's 95 degrees, right? It's not quite a right angled triangle, but it's really close. So it'll look something like this. Yeah, it'll look something like this. This will be the 95-degree one. This will be the 35, and this will be the 50. Pretty straightforward once you have a go at these questions and get a bit more practice. Okay, let's move on to the next one. Question number 3. As always, pause the video here and just take a second for yourself to read through the question. Okay, now that you've had a read through the question, let's go and find the key pieces of information. A rectangular field measures 20 meters by 15 meters. Calculate its perimeter. Okay, again, I've just provided an image to help out, but again, don't expect the image to be provided to you. If it's not there, draw a diagram for yourself. A rectangular field essentially just means we're dealing with a rectangle, yeah? And we've been told the length and the width. So the length is 20 meters and the width is 15 meters. What are we being asked to figure out? The perimeter. Okay, perimeter is basically when you add all the sides together, right? It's not the area, the perimeter. So you're looking at the distance around the shape or the field in this example. We know that these sides are going to be equal, so we know it's 15 meters like that. So it's 20 plus 20 plus 15 plus 15. 20 plus 20 gives us 40. 50 plus 15 gives us 30, which means our answer is 70 meters. So our perimeter is 70 meters. Pretty straightforward question once you use a diagram. Okay, let's move on to the next question. Question number 4. Again, pause the video here and take a second to read through the question. Okay, now that you've had a chance to read through the question, let's go through it together. A jar contains 4 red balls, 6 blue balls, 5 green balls. What is the probability of randomly selecting a red ball? So this just, it's a very simple probability question. We're being asked the probability of picking or randomly selecting a red ball. To figure this out, we need to know how many red balls we've got in the bag, so the number of red balls. Not the bag, sorry, the jar, and the total number, yeah? The total number in the jar. we have got 4 plus 6 plus 5, right? So how many red do we have? We've got 4. And then total is 4 plus 6 plus 5, which means it's 4 over 15. So that's a probability of choosing a red one. Too easy. Next question. Okay, for the final question today, again, pause the video here and take a second to read through it. Okay, now that you've had a chance to read through it, let's go through it together. A taxi company charges a flat rate of $5 plus $2 per kilometer. If a passenger pays $19, how many kilometers did they travel? With questions like this, it's really important to ask yourself what you're trying to figure out or what you're trying to calculate. A lot of students kind of rush through the question, and sometimes they don't, figure out how many kilometers, and they might figure out something else. So make sure you read through the question and understand what you have to figure out. So we've been told that there's a flat rate of $5. Sometimes when terms like this are used, students tend to, oh, what's happened there? Students tend to panic, but a flat rate just means it's just like an amount that's charged even before you start traveling in the taxi, right? Like you're going to be charged that $5, and then depending on how many kilometers you travel, that additional amount has to be added. So the rate that's depends on the number of kilometers is added to that $5. So you're going to be using $5. You're going to be spending $5 no matter how many kilometers you travel, essentially. So in a sense, we're going to be working backwards in this question. We've been told we've been told how much the passengers paid already. So the passengers paid $19. And before I said that the flat rate gets charged no matter what, right? So in that case, we need to take that $5 away, right? Which leaves us with $14. Now this 14 is essentially what the passenger paid for the number of kilometers that they traveled. So we've been told that it's $2 a kilometer. And remember, we're working backwards. We know that we've spent $14 on the kilometers, right? So let's look at the relationship. So how do we get from 2 to 14? We're doing times 7, right? 2 times 7 gives us 14. Remember when you're doing these like calculations and you're like comparing two rates essentially, only use multiplication or division, not addition or subtraction. If we've done that to one side, we need to balance it out by doing the same to this side. So 7 kilometers. And that's our answer. The passenger traveled 7 kilometers.